Writing a type-safe HTML template language for Rock. So at my job, one of the main things my team does is build this internal admin tool that administers a lot of different parts of our business. You know, it's just used by our employees. And it's a good old-fashioned server-side rendered HTML app. We're using Spring Boot. And one of the components we use to render the HTML, or the component rather, is Apache FreeMarker template language. So even though it's a part of Java, it's dynamic in nature. And I will say that I like it quite a lot because it's a big component of why we can ship software so fast. And when we say, hey, we need to make this change for these people, we have it in production in like an hour. Like, it's great. It's simple to understand, and it helps us deliver a lot of value. So here on the left, we have the FTL file. It's just HTML, but then you enrich it with these tags. So I'm saying, OK, interpolate this name value. Then on the right, I have my controller. So this is how I specify an endpoint in Spring Boot. I say, OK, I have this page, hello world. This method is going to accept a parameter called model that's a map from string to object that will contain all of the data needed to render the template. So then you just put whatever you want on the model and then reference the keys that you put on the model in the template, and you're off to the races. So this is really nice. It's simple, easy to use. It's great. I like that part about it. But there's trouble in paradise. You know, not everything is all sunshine and rainbows about this because there are a lot of runtime errors that show up. So let's say that I misspelled name on the model and instead it's NAM. Well, then when I try to load this page, boom, I get a runtime error. You know, okay, so I screwed it up, name is missing. And whenever this happens, depending on how you configure the template language, it will either blow up it completely and the page will not render at all, which is obviously not good, or it'll silently fall back on a default, which is usually just not rendering anything, which is also not good because then your page can just silently break and you don't even realize that part of it's not working. So this is not good. Well, what if name ends up being null? This can happen a lot in Java. Nulls everywhere. Oh, same error. OK. What if I forget to put name on the model at all? Well, same error. Name's missing. This can happen if you have multiple code paths where you're initializing the model differently based on some error validation or something like that. Or what if I spell something wrong on the template? Guess what? Now name is missing. You know? So the point is there are lots and lots of ways to get runtime errors, and this is just a small selection of ways. So there's more. In FreeMarker, you can also you have these list directives, and so here I'm putting a map on the model with integer IDs and string values, and I want to iterate over that map and show the values, and this works. This is nice. It's easy. This is completely valid. But then, suppose that I do something that looks completely innocuous here. I say, OK, give me key number 123 in that map, and then stick it on the page. Guess what? Uh-oh, it explodes. And it turns out that FreeMarker has some weird limitation where it's like the keys have to be something that is string or can be automatically convertible to string, but for some reason I can still iterate over the map if it has integer keys. Like, whatever, like that's fine, I guess. But this is the kind of thing you're only going to find out about this by doing this thing that you expect to work and then it blowing up and then being like, why is this not working? And then going and figuring it out. So it's not great. And really, the thing is, it doesn't have to be this way. These are solvable problems. We can fix this. And so that's why I'm very happy to come here and tell you that we can use the Rock programming language and its particular blend of features to maintain the nice dynamic experience of a language like this, or Jinja, or Handlebars, or many dynamic template languages, while getting compile time validation and removing any sort of weird limitations on what you can and cannot do in the template language. So I'm Isaac Van Doren. I'm a software engineer at Patient. We are on a mission to help people access and afford healthcare by making it easier to pay for. It's a great company. We have an excellent engineering team, and we are hiring. So check out the jobs page. All right, so what is Rock? Well, Rock is a fast, friendly, functional programming language. So that means fast in terms of compile time and runtime. So first, compile time. Having a fast compiler makes a language so much nicer to use. You can iterate so much faster. You can just focus on actually making changes. It enables a lot of designs to work because you don't have the restriction of long compile time, such as this template language that I wrote. It's also fast at runtime. So Rock is memory managed, and the goal is to be as fast, at least as fast as mainstream memory managed languages like Java, Swift, Go, etc. And there's a lot of interesting work that goes into making that happen. It's also friendly. This means that when you do something wrong, the compiler will give you a helpful error message and say like, hey, I got this, I was expecting that, I think you should change this thing over here, and then it'll work. And a lot of the time, it's just, oh, that's exactly what I meant to do, and now I can fix it, and it's just a great experience. This also means friendly to new users, so Rock should be easy to onboard for someone who is maybe not as familiar with functional programming. And then finally, it is functional. So Rock is a statically typed pure functional language. It's a descendant of Elm, so it has a lot of the same design decisions as Elm. But unlike Elm, which is for writing SPAs specifically, Rock is more general purpose. So you can use it for writing web servers or CLIs or even a lot of sort of apps in niche domains, like the long tail of domains. There's a lot of interesting stuff there that you'll have to come to a different talk about. And so this template language, the CLI is written in Rock, and then I'll use it in a web server that's written in Rock as well. So first I have to address the skeptics here. Why not just use functions? And the answer is, this is a perfectly reasonable thing to do, and it's a great choice, and it works really well. So here I have some Elm. Elm has a really nice DSL. It's just functions that you use to build up some HTML. So you compose them together. The first array is the attributes, the second array is the values that the tag contains, and it works really nicely. So that's a great choice. But there are still some reasons why you might want to use a template language instead. So one of the big ones is that template languages are not limited to HTML specifically. Now I know the title said an HTML template language, but RTL could be used with any content type. So if you have XML or YAML or bash scripts or whatever sort of cursed thing you want to cook up, you can still use a template language with it. And one facet of this is that it means if you have some existing piece of content, you can use RTL with it, and you don't have to try to convert it to the template language. So at work, we also integrate with some parallel systems. And there's one parallel system, which I will not name, where we have multiple 1,700 line XML templates of the most disgusting looking XML, and we stick some data in there using FreeMarker, and then we send it on over the parallel systems, and it works. And so just to give you a taste, I don't want to try to convert this into a bunch of functions. I'm going to leave this file be, and I'm going to stick whatever data I need in there, and that's great. So this is a great use for a template language. There are other benefits, like the input looks like the output, so what you see in your editor is what you see in DevTools. It also, in template languages, it's content first, and then the control flow is sort of like, the content is like a first class, and whereas in a DSL, it's like the control flow is first class. So I think in template engines, it's a little easier to focus on the content editing side. But ultimately, it's really just personal preference, and templates can be a nice tool. So now that we've gotten that out of the way, we'll show you some RTL. So I wrote a template language called Rock Template Language, or RTL, for the Rock programming language. And the template, you'll notice, it looks fairly similar to something like FreeMarker or Jinja or Handlebars, et cetera. So the data that's passed into this template is called model. I can access any fields on that data by referencing them on model. Here, we'll say this is like a blog engine, and I want to render a blog post, for example. So a user types up their blog post in whatever editor, and then I store that, and then I want to render that. So here I'm inserting the title and the author and the date, whatever. The double curly brace is how we do interpolations into templates. Okay, cool. Now, the content of the blog post is going to be a list of different blocks that could be of different types. So I could have a code block, just a paragraph, I could have an image. Those are the things that we're allowed to interpolate into the document. So what I need to do in that case is I need to expand over this list. So post on model is the list of the blocks that make up the blog. And then Rock has some types, algebraic data types, and we can pattern match on those directly in the template using a when expression, it's going to be a case expression in other languages. So now I'll say, okay, when that block is a code block, then format it using a pre-tag. When it's an image, then, render the image. When it's text, then just show a paragraph. And there we go. Now, moving on, I also have if-else, and there are a couple other things, but these are the highlights. So then, this is my template. I put it all together. I get a template file that looks something like this. This will be called blog.rtl. And then what I'm going to do is run the RTL CLI, which very quickly generates a file called pages.rock. And then it runs rock check on that file to validate that there aren't any preliminary mistakes at that point. Then, now that I've generated this module, I can write my web server. Writing a web server is very easy in Rock. It's great. It's super easy to spin up. It's a great experience. So I have a web server here, and I import pages, and then I call pages.blog. That's the function that was generated based off of the name of the template that I specified. And then I just write down my data and pass it in. And the key thing I want to emphasize here is that it looks like I'm writing down like a JavaScript object or like a Python dictionary or something. Like I'm not writing down any type annotations anywhere. I'm just writing down the data I want and throwing it on the template. But we have full type information going on here. Okay, so now I've done this. I can run my web server, and ta-da, I get my HTML and all of its glorious beauty. So there we go. So I see the paragraph, and then it renders the code block that I specified, and then shows that rock logo. So great. Now, I think at this point we've emulated a lot of the important features of a dynamic template language in that it's low hassle, it's easy to just whip it up, so cool. But there's nothing too new about this. Well, I'm not claiming this is necessarily novel, but it's for rock. So the question is, well, we also want compile time validation. So how do we get the compile time validation? So let's say that I misspell is authenticated and spell is authenticated instead or something. Well then, guess what? When I try to run my server, Rock says, hey, I need a record that has is authenticated on it, but you gave me one with is authenticated. I think there's a typo. You should probably change to use something else here. Okay, wonderful. Now, what if I forget the whole user altogether? Then Rock will say, whoa, 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 I needed a user, but you didn't even give me one, and this is the shape of the user that I'm looking for here. Or I could say, for this image tag, the width is supposed to be an integer, but what if I forget that and I pass it in as a string, then it says, hey, whoa, I need an image where the second argument is a string, not a number. So the point is, the compiler tells me anytime I do something wrong, and yeah, so this is very nice, at least I think so. Now, this goes both ways. If I'm on the template, I can mess something up here as well. I can say I misspell code, and then when I try to run it, it'll tell me, oh, another typo here. So this prevents a whole swath of issues that came up using FreeMarker and many other dynamic template languages. Now they're just gone. Now the compiler will tell you immediately. You don't have to run the code. You don't have to try to make sure you test all the code paths. The compiler will do it for you. Okay, so to emphasize how RTL works, well, first we parse the template, then we generate code. That's it. It's extremely simple. So the important thing to note here is that RTL doesn't know anything about rock. We are just parsing we're just parsing the RTL tags. So when you write an interpolation the RTL doesn't parse the contents of the interpolation. It just says, here's the beginning of an interpolation, here's some text, here's the end of the interpolation. And then that gets put into the generated code. This means that RTL is very simple. It's easy to implement. There are a whole bunch of things that will not go wrong because it's not trying to parse rock syntax or do type inference or do all of this stuff. So it's very simple. And the reason we can have such a simple design and yet get such a nice experience is because of some of Rock's features. So why does it work? Well, there are 4 things I want to highlight here. There are more reasons, but there are 4 main ones. So those are structural records and tag unions, type inference, open records, and pure functions. All right, let's get started with structural records. So in Rock, 2 records have the same type if they have the same fields, not the same names. So I can define my LambdaConf record here. And notice I'm not assigning some type name to this record. I'm just saying this is a record that has an integer ID and a string name. So if I choose to write a type annotation down, then the type annotation reflects the structure of the record. Again, there's no name associated here. It's just based on the structure. So Elm also has structural records, for example. There are a number of other languages that do, but they're certainly not the default. Compare this to Java, for example. Java has nominal records, so I would define explicitly on a new line my record called conference. It has the same fields as before, but it is defined by the fact that it's named conference. So then if I want to create one of those, I have to invoke the name conference, pass in the data, and then I get a conference back specifically. So now when I say I want to call a function that accepts a conference, and I pass in a meetup, where a meetup has the same content, it also still has an integer ID and a string name, well, this is going to be a compiler error. And this is completely intended. It's because a meetup is not a conference. They have different names. They are different things. Now, quick side note here. This is really useful for a lot of things, like hiding implementation details and enforcing validations. And so Rock has a way to opt into this called opaque types. So you can get all of this functionality still. It's just not the default. So Great. Now, why does this help us in RTL? Well, it means it's a key part of why we can get that dynamic feeling where it's just like I'm writing down a JavaScript object, because I don't have to have some big type annotation exactly specifying the data that I'm passing in, and yet I still get that type annotation. So here I just write down the record I want. It's a record with post and title, and there we go. We're off to the races. Compare this to Java, for example. You'd have to write down explicit type annotations for everything you're doing. So I have to say, this is my blog page model, this is my post item. To declare my post type, then I have to create all of them. Like, this is not horrible, but it's bad enough that I would not want to do this. Like, I'm not going to use this tool. This is not as nice as FreeMarker anymore. And I'm not hating on Java here specifically. This is most statically typed languages. Also, another point, I'm not hating on FreeMarker either. This is most dynamically typed template languages. Okay. So we need another thing. I've lied. Structural records are not all we need to make that last part work. We also need type inference. So suppose that I define this beautiful structural record here for a person. Then I have to write down this stupid type annotation. Like, do you see how many fields are in that type annotation? I do not want to write that down. You know, then every time I have to update the record, I have to also update the type annotation. It's just more verbose than writing down a separate declaration. I guess it's about the same, but fortunately, Rock has type inference, so it will infer the type of the record based on the fields, and I don't have to explicitly declare it. So, ta-da, this is what we get instead. We don't have to write that annotation. Now, this is not controversial. This is used in many programming languages, including Java, for example, where you can have type inference on the level of a definition. So I'm declaring something in my function, and I don't have to specify the type there. But many languages impose the constraint that your function needs to be fully annotated. Any function you define on the top level needs to be fully annotated. So you don't need to say it accepts these parameters of these types, and it produces this result of this type. And that is a problem for us. That would not work with our design, because then what we'd have to do is in our generated function, say I have a template called user, then I'm going to need to annotate that function. Then the question is, where am I getting this type information from? So I'm going to have to either write down this type in, somehow I'm going to have to write that down in the template, or I'm going to have to import it from one of the modules that uses the template, but then there could be multiple modules that use the template. So like that doesn't seem like it's going to work. Or, and regardless, I would still have to update the annotation, which is a pain. We're trying to avoid that. Or I could maybe, like, RTL could do type inference on the template or something, but that's a whole can of worms, you know. So this is not going to work, and fortunately, that's not a problem because Rock has complete type inference. So ta-da, it just works. We don't have to write down the annotation. What the Rock compiler will do is look at the contents of that function, see how things are used, and then it can determine the type of that function all on its own without you specifying it. So Rock can infer the types of everything in your program without you writing any type annotations. And this is very useful for cases like this. Now, in practice, people still do write lots of type annotations because they're very useful. They make your code easier to understand. They can improve error messages and so on. But in a situation like this, it's very helpful that we don't have to explicitly annotate this function. All right. There's another thing, structural tag unions. So in Rock, I can just define my post right here. That's a list of these tags. And I don't have to have any external annotation. I just say I want text, and it's going to have a string, and then I'm going to have an image and a string and an integer. It works. So now the compiler will infer this type for this tag union, or we could write down this annotation. And note that the type of the tag union, it's not just like a name. It reflects the structure of the tag union, how we're using it, much like structural records did. Compare this to Elm, for example. Elm has nominal tag unions, as do most languages that have them. And so here we have to explicitly define our post type with these variants, and then we can use it later. And note that these variants, the text, code, and image, they're like inextricably linked from post type. Like they only exist as members of post type. That relationship is very strong. So why is this useful for RTL? Well, first, it's useful for a lot of things outside of RTL. It makes API design better in a lot of cases because there's no overhead if you want to reach for like a tag union for the parameters to your function or something. And then you can look at the function signature and just see, oh, these are the different variants it accepts. So it's nice for a lot of things. But one way it's useful for RTL is that it helps us define our data quickly and easily. So like in the previous example, the reason that I can just write down my post here like that is because of structural tag unions. Otherwise, I'd have to declare the tag union elsewhere, and then I would have to deal with that. So, but the biggest reason is that it allows us to have ergonomic pattern matching on tag unions in our template. So I can, if we had nominal tag unions, I would have to import the type declaration to be able to pattern match on it in the template, because that's going to have to be imported to the generated code. And this is not good. Like, I don't want to do that. I don't want to have to write down this import, figure out how to make that happen. This, again, is another piece of ceremony, another paper cut on top of the dynamic experience that we're trying to keep. Okay, well, fortunately, because they're structural in Rock, we don't have that. The generated code doesn't have to import that type signature. So, wonderful. Now, there's one more type system piece. A common thing I do when I'm working on a template is I'll make some database queries, call some services, I'm gathering my data up, and I might be throwing it on the model, that map, but I haven't updated the template yet. But wait, this is going to break, isn't it? Because what if we have a template that only has a title on it? Well, then the inferred type of the function for this template is only going to know about title. So then when I try to pass in this record that also has a post and a name on it, the compiler is going to complain. It's going to blow up and say, well, that's not what I was expecting. But fortunately, that's not the case, and that's because Rock has what we call open records. So in Rock, that I can define a function that accepts a record that has at least these fields. It could have more, but all I care about is that it has at least these fields. And that solves this issue, and it's also very useful in lots of other cases. All right, last thing is pure functions. So pure function is one where the implementation could be replaced with a lookup table behind the scenes, perhaps an infinitely large lookup table, and that would not change anything. So a pure function can't depend on any external state, it can't do any side effects, anything like that, and that's what Rock has. All functions are pure in Rock. So other template languages frequently define their own sort of standard library to use on the template. So for example, in Jinja, I could have a list, and then I want to join them with this pipe, and then I want to check if that list is empty. I know it's contrived, but I'm just showing you how you can pipe these values together. It's nice, you can do it in one line, you don't have to have multiple statements, it's easy to use. FreeMarker does the same thing, they have their own language. And note that this is Jinja and this is FreeMarker. This is not Python and Java. These are different languages. These are different things you have to learn. They have different semantics. There are gotchas. Like the map example, there are things that vary that we have to worry about. But guess what? In Rock, on RTL, you just use Rock. Every expression is normal Rock. There's nothing extra. You use the same standard library that you used to, and there are no differences in semantics. Now, why is this? Well, I think part of the reason is that in a language like Python or Java, a good part of your standard library operates by mutation. So if you want to add something to a list, you mutate that list instead of accepting a list and the value and returning a new list. So, and that prevents you from being able to compose things easily on the template like you want to. So then you're encouraged to define something like this. It's also that you may be using an approach where the template language actually has to know about parsing the syntax of the expressions, in which case then you want to implement your own smaller library that you can handle instead of dealing with the whole standard library. But guess what? We don't have to worry about that in Rock. So this is very exciting to me because I think we can eliminate some of the biggest issues that people have with template languages. Namely, you get help from the compiler now. It's not just the Wild West. There aren't weird limitations on what kind of code you can use in the template or not. And there aren't weird differences in how things work that you're not expecting from your core language. So recap. Simple design works because of tag union, structural records and tag unions, type inference, open records, pure functions. And because of this, we get similar experience to dynamic languages, no runtime errors, no new standard library, and no arbitrary limitations. All right, so, and we can do this because of Rock's particular features. So these features are useful in this case, and this solution would just not work without the features. But they're also useful in lots of other cases. And it's been a lot of fun for me to get to explore Rock and use some of the new features that I haven't been used to in other languages, and get to see what sort of things fall out nicely and what things work well. So my most important point is I hope that you feel inspired to go try Rock, try some of these features, and see what it's like. So that's it. Here's some links. Check out Patient, Rock, RTL, me. This content will also appear in a forthcoming book, Software Design by Example in Rock. And yeah, we don't have time for a Q&A, but I would love to talk afterwards, so please come find me. Thank you.